In this question, we are given the position of a toy car moving along a horizontal track given by this function, that is c of t equals under the root of t plus 2 and t greater than or equal to 0. And we have to determine the time t such that t lies in the interval from 2 to 7, and also this average velocity equals instantaneous velocity. So let's see how to determine the time t such that the average velocity equals instantaneous velocity. So first, let's write the formula for average velocity. This is basically the change in position between the time intervals divided by change in time. So using this position function, I'm going to write down this change in position for this time interval, that is from 2 to 7. So I write down this as c of 7 minus c of 2. This is change in position for the time interval t from 2 to 7 divided by change in time, that is 7 minus 2, and this is basically the average velocity, and this equals instantaneous velocity. Instantaneous velocity is basically the derivative of the position function c of t. So I write down this as c prime of t. Now let's evaluate this. We have to find c of 7, so we plug in c of t by 7 into the c of t function. So we get c of 7, and this equals under the root of 7 plus 2. And then we find a c of 2 by plugging in t equal to 2 into c of t. So we get under the root of 2 plus 2. And this is over 7 minus 2 is 5. This is 5. And this equals we have to find the derivative of the c of t function. So let's copy the c of t, and this equals under the root of t plus 2. We can rewrite this in exponential form, that is t plus 2 raised to the power of 1 half. Now to find its derivative, we apply the power rule. So therefore c prime of t, and this equals 1 by 2. We put the power in front and reduce it by 1. So therefore this becomes t plus 2 raised to the power of half minus 1. And so let's simplify this. So this equals 1 by 2. T plus 2 raised to the power of half minus 1 is negative half, and so we can rewrite this as 1 divided by 2 times of t plus 2 raised to the power of positive of, which we can write down as under the root of t plus 2. So basically this is the expression for the derivative of the c of t function. So I'm going to copy that over here. So I write down 1 over 2 times of t plus 2. Now let's evaluate this. So here we have 7 plus 2 is under the root of 9, minus 2 plus 2 is under the root of 4, and this divided by 5, and this equals 1 divided by 2 times of under the root of t plus 2. Let's simplify and solve for t from this equation. So square root of 9 is 3, and square root of 4 is 2, and this is divided by 5, and this equals 1 by 2 t plus 2 under the root. So on the left side we get 3 minus 2 is 1, so it becomes 1 fifth equals 1 over 2 times of under the root of t plus 2. Now let's cross multiply as like this and the like this. So we will get 2 times of under the root of t plus 2. This will get multiplied with 1. So I just write down this as 1, and this equals 5 times of 1 equals 5. So now let's simplify for t. So I can divide by 2 on both sides. So I get under the root of t plus 2, and this equals 5 by 2. Now, since we want to solve for t, we square both sides. So when we do that, we get t plus 2 on the left side, and this equals, we have to square this 5 by 2. And so this equals 5 squared divided by 2 squared, which is 25 over 4. So I write down 25 over 4 here. Now t equals, we have to subtract 2 from both sides. So when we do that, we get 25 by 4, minus 2. Let's simplify this. So this is 25 over 4, and this 2 can be written as 2 times of 4 divided by 4, and this equals 25 by 4, minus 2 times of 4 is 8 fourths. So it's basically 25 minus 8 fourths, and so this is equal to 17 fourths. So this is the value of t, such that the average velocity equals instantaneous velocity. And so answer choice A is correct. Let's answer this question. Here we are given the function g of x equals 5 plus 3x minus x cubed, and we have to determine the minimum value of the function on the interval negative 2 comma 1. So first we have to find the critical point of this function g of x. You can find the critical point by setting up the first derivative of the function equals to 0 and solving for x. So let's find the first derivative of g of x, which is written as g prime of x. And this equals, we have to find the derivative of the right side expression. So the derivative of 5, which is constant, is 0. And then the derivative of 3x is just 3, because the derivative of x is 1, minus the derivative of x cube is, when you apply the power rule, we will get negative 3x squared. So let's simplify this. So this equals 3 minus 3x squared. And to determine the critical point, we have to set up g prime of x equals 0. So therefore, I set this up equal to 0. And let's focus. I'm sorry about it. So let's focus about this equation. So we have to determine x from this one. So 3 minus 3x squared equals 0. First we add 3x squared to both sides. So we get 3 equals 3x squared. Now dividing both sides by 3, we get this divide by 3 and this divide by 3. And so on the left side we get to 1, and this equals, on the right side we get x squared. And this means we take square root on both sides so that we can solve for x. So we get plus or minus 1 is the square root of 1, and this equals square root of x squared is x. So we get two values of x, that is x equal to 1 and x equal to negative 1. These are the critical points of the function. Now we should determine at what critical point the function g of x is minimum. So for that we can use the second derivative test. So let's find the second derivative of the function g of x. Let me copy the first derivative, that is g prime of x, and this equals 3 minus 3x squared. Let's find the derivative of this one. So derivative of g prime of x, which is basically the second derivative of g of x, written as g double prime of x, and this equals derivative of 3 is a constant, and derivative of negative 3x squared is negative 3 times derivative of x squared is 2x. So this basically equals negative 6x. Now let's consider the critical points, that is x equal to 1 or x equal to negative 1. We have to plug in this critical point into the second derivative function. So let's do that. So I'm going to plug in g double prime of 1. That is, when x equal to 1, this becomes negative 6 times of 1. And so this is negative 6. And this is less than 0. So when the second derivative is less than 0, it's a point of maximum. And since we want to determine the minimum value of the function, we should basically get the point when the function is minimum. So now let's put the next critical point, which is negative 1, into the second derivative. So we get g double prime of negative 1, and this equals negative 6 times of negative 1, and this equals positive 6, and this is greater than 0. So here the second derivative is a positive quantity, and this means the critical point x equal to -1 is a point of minimum. That is, the function attains the minimum value at this critical point. So now we have determined that at x equal to -1, the function is minimum. So we can determine the minimum value of the function by substituting x equal to -1 into the original function g of x. So let's do that. We have to plug in x equal to -1 into g of x. So we get g of -1, and this equals 5 plus 3 times of -1 minus -1 quantity cube, and so this gives 5. 3 times -1 is -3, and we have minus -1 cube is -1, so we get 5 minus 3 is 2, minus this negative of -1 is plus 1, so we get 2 plus 1 equals 3. So we have determined that the minimum value of the function is 3. And so answer choice C is correct.